Okay, I'm going to give a bit of a synopsis of the graph of a quadratic function. This is by way of review, but we want to see this as it develops logically, mathematically. Okay, quadratic function. Quadratic function can be written as y equals f of x equals ax squared plus bx plus c. Okay, if it can be written this way where a, b, and c are constant numbers, constant real numbers, then this is a quadratic function. And if it's a quadratic function, it can be written this way. It's called the general form of a quadratic function. There's also a standard form of the quadratic function, where y equals f of x equals a times the quantity x minus h squared plus k. Now you can see from the form of this that this is just like the y equals x squared function. If you shift it horizontally h units, stretch it vertically by factor k, a, and shift it vertically k units. Okay, right there it is. Now, you should see that because, of course, you recently studied transformations. Now, having said that, for most students, transformations don't really make a whole lot of sense at this point. And we can make more sense out of transformations if we do them in terms of quadratic functions. But right there it is. And if you really understood transformations, you understand what I just said. We'll come back around to that. Okay, well, quadratic formula. What's a quadratic formula say? Well, it says that we could write it this way, that f of x equals ax squared plus bx plus c equals 0 if and only if x equals negative b plus or minus square root of b squared minus 4ac over 2a. Now, most people think the quadratic formula is just this. Okay, well, maybe so, but you have to know what it means. And when you state the formula, you should be stating, in my opinion, what it means. Okay, and this is what it means, and this is how it's going to apply to quadratic functions. Okay, well, it's one idea. Another idea, the standard form implies that the quadratic function is symmetric about the vertical line x equals h. Okay, now, I'm not going to belabor that fact right now, but just accept it because the x minus h quantity is squared. If x is on one side of h, let's say x is 5 greater than h, then x minus h squared is 25. But if x is 5 less than h, then x minus h is negative 5, but negative 5 squared is still 25. So whichever side of h x is on, there's an x on the other side of h that gives you the same value, and that makes it symmetric. We want to put these two things together into a more or less complete picture of the graph of the main properties of a graph of a quadratic function. So we're going to come over here and we're going to say this. If x equals this, then it equals this. In other words, negative b plus or minus the square root of b squared minus 4ac divided by 2a by the distributive law is negative b divided by 2a plus or minus the square root of b squared minus 4ac divided by 2a. For the same reason that 3 plus 7 over 8 is 3 over 8 plus 7 over 8. It's a distributive law because division is just multiplication by reciprocal, since it's distributive law of multiplication over addition. Okay, we have this. Now, if we have a quadratic function, the x values given by this expression are the values that you plug in to get 0. Okay, well, let's postulate an x-axis here. And whatever negative b over 2a is, we're going to put a point here and say that's where negative b over 2a is. Okay, look at this expression, negative b over 2a plus or minus the square root over 2a. So where are these values of x? Well, negative b over 2a plus the square root of b squared minus 4ac divided by 2a is this far from negative b over 2a. I'm assuming that a is positive. If it's negative, then we just reverse these. So we go this far, and here's a value. F of x is 0 here. Because here is negative b over 2a plus the square root of b squared minus 4ac over 2a. Things getting a little sloppy there, but there it is. And here, f of x is 0 here, for a similar reason that I'm not going to clutter up the board with. You should understand that. It follows that if you have symmetry around some vertical line, x equals h, that vertical line has to go through this point, because you have a point of the graph on this side and a point of the graph on this side at equal distance. The only way that could be, if you have an axis of symmetry, which you do, is if the axis of symmetry goes through negative b over 2a. So negative b over 2a is symmetric with the zeros of f of x. So the vertical line of symmetry is through the point negative b over 2a, 0. The equation of the line of symmetry is x equals negative b over 2a. And that equals h. So now we have a couple of connections between this form and this form. In the first place, I didn't say it before, but it's obvious. This form and this form. I don't know what I'm pointing over there for. Okay. If you expand this, x minus h quantity squared is going to be x squared minus 2xh plus h squared. Multiplied by a, you're going to have ax squared here, just like you have ax squared here. So this a is the same as this a. And these a's are the same. Also, h is the axis of symmetry, but negative b over 2a is the axis of symmetry. Okay, so Axis of symmetry is negative b over 2a. Axis of symmetry is h. So h equals negative b over 2a. Now you can get that just from the algebra. You write this out and expand the square and then see what the coefficient of x is. It's going to be 2ah. And that's got to equal b. Well, if 2a times h equals, actually it's going to be negative 2ah. And if negative 2ah equals b, then h is negative b over 2a. So there are all kinds of ways you can see this, but you should know this and believe it. Now, in a minute, we're going to apply this to constructing a graph. Okay, so let's let y equal f of x equal x squared plus 4x plus 4. We want to sketch the graph of this function. We're going to use what we just saw. A equals 1, B equals 4, C equals 4. If we agree that the function is in the form ax squared plus bx plus c. The axis of symmetry is a vertical line. X equals negative b over 2a. Well, that'll be negative 4 over 2 times 1, which is negative 2. The zeros are at x equals negative b plus or minus square root of b squared minus 4ac over 2a. And that equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4. All that divided by 2 times 1. And that's going to equal, simplifying, and I'm not going to go through all the details. You've been through them. You understand how to use this. Negative 2 plus or minus 0. Okay, so what are we going to do about that? Well, we know then that the graph is going to have a 0 at x equals negative 2. We also know it's not going to go through the x-axis at any other point. Well, another thing we know is that f of x is a times x minus h squared plus k. In this case, that's 1 times x minus negative 2 squared plus some number k. Which is x plus 2 quantity squared plus k. This is y equals x squared shifted 2 units to the left and raised k units. So we can now sketch the y equals x squared graph. Put 4 up here. And without going through all the details, we do the usual subdivisions. We plot our points. We sketch our curve. And here's our y equals x squared graph. And then we shift this graph 2 units to the left. So the vertex shifts 2 units to the left, and let's use a pretty color to do the shift. This point is going to shift over 2 units to give us this point. And we better get this point because we know this point is on the graph because that's where the function is 0. And then we shift this point to the left 2 units. And we shift this point to the left 2 units. We shift this point to the left 2 units. And the same thing with the other points. And when we've done that, I'm going to find that our graph looks like this. Didn't do a real good job of that, but just this graph shifted 2 units to the left. Okay, well, these are all techniques that we understand by understanding everything that's gone up to this current section 3.2 of the text. So there's kind of a review involved here. We've used a lot of ideas in different sections, and we put them together, and we've managed to graph this function. Now, I don't have a lot of room here, but let's just see what happens when a graph y equals f of x equals x squared plus 4x minus 2. Well, let's find the zeros. Now, I'm not going to write out a, b, and c. We all know how to do that. We have zeros at x equals -4 because it's negative b, plus or minus the square root of 4 squared, that's our b squared. Minus 4ac would be minus 4 times 1 times -2. All that divided by 2 times 1. And that comes out -4 plus or minus the square root of 24. All that divided by 2. Let's make sure that 24. 4 squared is 16. 4 times -2 is plus 8. 16 and 8 makes 24. And then what's the square root of 24? Well, take a calculator, but 24 is between 16 and 25. Square root of 16 is 4, square root of 25 is 5. This is right next to the 25. From 16 to 25, the distance is 9. This distance is 1 unit from 25. Even though there's some curvature to the graph of the square root function. We can do a 1 decimal place approximation and have some confidence in it. Be 5.9 over 2. And I don't use a little wavy equal sign because this is an approximation. It's not an exact calculation. You go to your calculator and calculate out to 14 decimal places if you want to. It's not going to make much difference if you're doing a hand sketch graph. 5.9 is good enough. If you want more precision for other reasons, of course, your calculator will give it to you. Okay? So this is -2 plus or minus 2.95. So your zeros are -4.95 and 0.95. Yeah, okay. I was looking at something very strangely. Okay, well, there it is. So now I can construct my graph. Your axis of symmetry is at -4/2. That's your -2. Okay. So if you do it in this form and separate the -4/2 from the plus or minus 5.9/2, the -4/2 gives you the axis of symmetry. It's sitting right there in your quadratic formula because there's -b/2a. And that's well worth knowing. Helps you remember where the axis of symmetry is. In case you forget, it's sitting there smiling at you within the quadratic formula. Okay, so we're going to have -2 here. And your axis of symmetry is right here. The zeros are at -4.95 and 0.95. So 0.95 would be maybe about here. And -4.95 would be way over here. Now the graph is located a little inconveniently. I'm almost tempted to redraw it. Matter of fact, I'm so tempted I'm going to do that. I didn't plan that very well. I smudged all this. This whole board's getting prettier and prettier, don't you think? Okay, I'm going to put my y-axis here to leave myself room to do this graph. I'm going to leave myself plenty of room over here. Okay, so I'm going to put -2. I'll put it here. So that -1 would be about here, 1 would be about here, 2 would be about here. So 0.95 is about here. There's one of my zeros. Remember, this is approximate. We'll get a picture. Okay, over on this side, I'm going to have, let's see, what, -3, -4, -5. Okay, well, over here at just before -5 at -4.95, I've got another zero. So let's see, that distance and that distance, they look pretty close. So we're going to be able to get a pretty symmetric graph. Okay, so now we know that we have this axis of symmetry. We could conclude that this graph is going to have the same shape as the y=x² graph. It's going to have to be shifted so that the vertex lies on this line and the zeros go through these 2 points, which means we're going to have to shift it down pretty low. But if I draw a parabola now through these points, there's a pretty good graph. If I want to know the coordinates of this point, and I often do, down where we can see that point. Okay, there's the point. Now, where is the vertex? Vertex is at x equals -2. What's the y coordinate? It's f of -2. This graph is your graph of the f of x function. And f of 2, just plug -2 in for x. You're going to get -2 squared, which is 4. 4 times -2 is -8. So 4 and -8 gives you -6, it gives you -4. And -2 gives you -6. So I'll write it out, -2 squared plus 4 times -2 minus 2. Now, that might be blocked by something Zoom puts on the screen, but you know what goes in there if you evaluate f of -2. And that's -6. So now you know that your vertex is -2, -6. If this is -6, then it looks like this thing passes through the x-axis about halfway between, passes through the y-axis about halfway between the x-axis and y equals -6, and that would be about -3. Of course, we know that we pass through the y-axis when x equals 0. And if x equals 0, actually f of x is -2. So it's not the best drawn graph in the world, but there we have it. So it's plausible, but not really believable that if this is at -6, that this is at -2. That really should be up a little higher. So still, it's a decent hand-drawn graph, or at least decent by my standards. And hopefully you have even higher standards. So make your best graph. Well, it tells you a lot about quadratic functions if you digest everything that we just went through.